Welcome everyone. I am Unjal Pal. Today we will solve a LeetCode problem step by step. The problem number is 3301, which is maximize the total height of unique flowers. Let's see the problem statement. You are given an array maximum height where maximum height of I denote the maximum height the ith tower can be assigned. Your task is to assign a height to each of the towers so that the height of the ith tower is a positive integer and does not exceed the maximum height. And no two towers have the same height. That means we have to provide each of the towers uniquely heights and return the maximum possible total sum of the tower heights. If it is not possible to assign heights, then return -1. So we need to maximize the sum of total heights. So what we need to do, we have to assign the maximum height we could possibly give to each of the towers. Let's see the constraints. The constraints are the length of the maximum height will be up to 10 to the power 5 and each of the element will be up to 10 to the power 9. So the algorithm goes like this. First we will sort the given array by decreasing order. The zeroth element will be the maximum element so that we know the maximum height which we could give to a tower. It is the first element. Then we will keep track the maximum height we give to the last tower, and we will decrease each of the time the height -1 so that for example here we will sort this, so it will be 4 3 3 2. So first we will give 4 height to the first element, and then we will give decrease the height by 1, then it becomes 3, then we will give this height 3, and it becomes then the current height becomes 2, then it is 3. We can't give 3 because our maximum height that we can give is 2. Then after giving this element 2, then our current maximum height that we could give will be 1, then we'll give this 2 height 1 because we can't give 2, it is already given to another height. So that's how we will do it. So let's make first sort the array. I will taking this as mx to write it easily. So sort mx dot begin, mx dot end. Now let's say long answer equal to 0. Now for each of the element present in max, we need to keep track the maximum height, currently maximum height, which is, let's say, current. Initially it will be the maximum height, which is mx of 0, because we are sorting this in descending order. To sort this descending order, it will be r begin and r end. Okay, it will let correct it will be not begin, it will be r begin and it will be r end. Then it will be sorted in decreasing order. Now the first element will be the maximum element, and this is the current height we could give to the uh, to a tower. Now each of the time we need to check. There is two possibilities. If all the current is greater than the current that the tower, because let's say the previous tower is height 10 and the current tower is 5. So after giving 10 to the previous tower, the current maximum height that we could give will be 9. Then we can't give the 9 height to this current tower because the maximum height that could we give the current tower will is 5. So we need to bring current at 5. So first we need to check if current is greater than the current height, then we will bring the current as IT. Next, now we could give the height to our this tower, so we will add it to our answer also. So answer plus equal to current. Then after giving the this height, we need to decrease the current by 1. That means the next tower will give the maximum height that could be possible. And another thing, you can see the height that we could give is a positive integer. So in any case, if okay, it is not third bracket, it will be second bracket. So it is by mistake, I got second bracket. So now we need to check if current is already 0. That means we can't give any other heights to our current tower. So then we need to return -1. Okay, that's it. And after that, the for loop, then we need to return the answer we got. Let's see, will it work or not? It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the time complexity, to sort this, it will take big of n log n time, where n is the length of the given max height. And this for loop is taking big of n time. So overall time complexity will be big of n log n. And the space complexity is, we are not using any auxiliary space, which is or length, which is depending on the length of our given maximum. We are just creating some constants, or you can say variables, which are to store this answer or sum, and keep track of the maximum height. So the overall space complexity will be big O of constant, or you can say big O of 1. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.